say calculate angular position in the first minima in front of our pattern of slit 10 to minus 6 meter wide if it is illuminated by light of wavelength 4000 angstrom unit. So it is clearly a case of single slit diffraction wherein the slit width is given. So we will be starting the solution of this problem. So it is A equal to 10 to minus 6 meter, and also first minima position is mentioned here. So m is equals to 1 and wavelength of light is also given, that is the 4000 angstrom unit. In meter it is 10 to minus 10 meter. We have to find out the angular position. So recall the formula. It is for minima position, you can write for minima we have a condition. So from this formula we can write this: theta is equals to sine inverse of this. Now putting all these values, so solving this we will get sine inverse of, okay, so sine inverse of 0.4. So this is the final answer. This is the angular position where we will see the first minima, that is first minima, and this angle we have just find out, that is the 23.57 degree. Now second problem, write what is given first, then we will see what is to be find out. Read this problem again, that single slit of width A, that is given 0.14 mm. The distance between the slit and the screen is given. So let us indicate that as a capital D, that is given 2 meter. And in the center of the second dark band is 1.6 centimeter from the middle of the central bright band. So indicate it as a small d, that is 1.6 centimeter. It's to be find out. Okay, the same thing what is mentioned in the problem, that can be put in the form of picture like this, that there is a slit, so we have to find out this wavelength. So for this dark band, in case of single slit, we know that the condition is A sine theta is equals to m times of wavelength. So as we are interested to find out the wavelength, therefore the formula will change to this. Okay, so from here we can say that A is required, sine of theta, that is angle of diffraction, is required then, and m is also required. So here m is also given. You can see here the second dark band, so write down this as m equal to 2. So from this formula we are in need of finding the theta, that is the angle of diffraction. So that can be find out from this geometry. Look at here, like if we join this center of the slit to the position of the second minima, then a triangle will be formed, and the angle made between these two line is theta. So here we can find out this angle comparing these two lengths. Okay, so there is a triangle over here, and we can find out here this angle theta. You know, this 200 centimeter in comparison to the 1.6 centimeter is very large. So this value of this angle is very small, will be very small, very small. Okay, so here we can comment that the theta is very small here. Therefore, as we know that from this triangle, you can see this, there is a triangle over here which looks like this, and this angle we have to find out. So it is opposite side that is known to us, that is 1.6 centimeter, and there is a adjacent side that is also mentioned. So we can find out tan theta here. Okay, so that will be 1.6 divided by 200 centimeter. Therefore theta is equal to, here instead of writing tan theta, we can directly write theta here, 1.6 centimeter divided by 200 centimeter. Okay, so we will put this here. in this formula. Therefore, wavelength is equals to A, that is given in meter, so we will write millimeter, that is we will write in meter with considering its multiplier. Then sine of the theta is theta, we'll write directly here, and the order of the diffraction that is given to. Okay, I just put these values and solve. Okay, so we are getting here 5.6 into 10 to the power minus 7. Okay, now what is the unit coming out for this wavelength? It is coming out as a meter. Okay, so we can convert this into angstrom unit this way. Okay, because this angstrom unit is 10 to the power minus 10 meter. So we are moving this decimal point to the 3 more decimal places to the right side. Therefore, the multiplier should also increase in number 3 but with negative sign. Therefore, the wavelength comes out to be the 5600 angstrom unit. Third problem is here. It is based on the diffraction grating. So I have already written here what is given. So let me read problem for you. A parallel beam of light is incident normally on a plane grating having 4520 lines per centimeter, and second order spectral line is observed at an angle of 30 degree, and we have to calculate the wavelength of spectral line. So we have to calculate the wavelength of spectral line. So lambda is unknown, the angle is also given 30 degree, and that is number of lines per centimeter is given, and the order mentioned here is n equal to 2. This is clearly a problem from the theory of diffraction grating. So here we will use the condition for nth order plane diffraction grating maxima. Okay, because here the spectral line is visible and we have to calculate its wavelength. Therefore, we will be using condition for maxima. So it is A plus B sine theta equal to n times of lambda. Okay, and as we know that this wavelength is to be calculated, therefore we need to arrange it. Let us just arrange it. This A plus B, that is the grating element, is inverse of the number of lines that is indicated by capital N. Therefore, we can write this A plus B as 1 upon n. So small n into capital N, right? Because A plus B is equals to 1 upon n. Therefore, now we can move ahead by putting the values of these quantities. Therefore, here lambda is equals to, okay, so therefore sine 30 is half, that half divided by this 2 into 4520. You can use calculator. Yes, what is answer? Answer is 5.530 into 10 raised to minus 5. Okay, so now what is the unit of this wavelength? Because the unit will be in centimeter, because 4520 are the lines per centimeter. Okay, so therefore this will be in centimeter. So after converting it, we can write this as 5530 into 10 raised to minus 8 centimeter, and also we can write it as 5530 angstrom unit. The fourth problem: what is the highest order spectrum which may be seen with monochromatic light of wavelength 6000 angstrom unit by means of a diffraction grating of 5000 lines per centimeter? So I have written here what is to be find out and what is given. Capital N is given, that is the 5000 lines per centimeter, and we have given this wavelength of light, that is 6000 angstrom unit, and we have to find out the order highest order, so we need to find out the n max. As this is clearly a picture of a problem of a diffraction grating, so we will use a grating equation, that is a plus b into sine theta is equals to small n into lambda. Okay, as we are being asked for finding the highest value of this, so this sine theta must be maximum, and the value for this sine theta is equal to 1. Okay, therefore rearranging this equation for n, that is max, we can write this n would be max when a plus b into sine theta is, that should be the max, divided by here the wavelength. And as we know that the value of sine theta is 1, and on the same time that a plus b on numerator is reciprocal of capital N, so we can just replace it this way, lambda into that a plus b, nothing but the 1 upon n, therefore this will be the capital N. Okay, because a plus b is equal to 1 upon n, and the sine theta is taken as a 1 for getting the highest order. Therefore now our formula has changed to 1 upon lambda n. Okay, so we can do this, we can put these values of this wavelength. So here 6000 angstrom unit is given, so we can write this into centimeters because the other quantity is in centimeters, multiplied by 5000 lines per centimeters and their reciprocal. Now take your calculator and find out this product. So it is coming 3.3. Order cannot be in decimal points, therefore highest possible order is n equal to 3.